Hi guys, welcome to another video. Today we will be solving class 9 polynomials, exercise 2.5, question 11 to 16. For the previous questions, please go through my previous videos. So the 11th question says factorize this. Now it is clear that we have this identity. Now the LHS is given to me. I will simply convert it to the RHS. So first let's write it in the correct form. So 27x cube I can write as 3x whole cube plus y cube plus z cube minus the identity says it should be 3xyz. So I will get 3 into my x is 3x into y into z. So this should give me this side. Let's write it. So I will get 3x plus y plus z bracket 3x square, which will give me 9x square plus y square plus z square minus 3xy minus yz minus 3xz. Moving to question number 12. Now it says verify that this is equal to this. Now I cannot solve LHS in this case because there's nothing to solve, as I can see. I can, however, convert it to the identity, but it's better to solve this side, the RHS. Let's see. So I'll write RHS. Over here, this I can see is the identity a minus b whole square, which should give me a square plus b square plus 2ab. Let's get started on that. So this will remain the same, x plus y plus z, then a bracket. This will become x square plus y square minus 2xy. This will become y square plus z square plus, minus 2yz plus z square plus x square minus 2xz. So I can clearly see it has 2x squares, 2z squares and 2y squares. So I will get 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2xz. Now everything has 2 common, so I can take the 2 out in the next step. So I will get half into 2, the 2 common from here, and the rest will remain the same. I will get x plus y plus z bracket x square plus y square plus z square minus xy minus yz minus xz. Next, this and this will get cancelled. Now, if I carefully look at the first identity that we had written, if I have this, it automatically becomes the LHS. So I can straight away after this write so I can straight away now write the identity x cube plus y cube plus z cube minus 3x y z, which is equal to LHS. So hence verified. Okay, so moving to question 13. Again, we can use the same identity as we used earlier in the above questions. Now I can see that it says x plus y plus z is equal to 0. Show that x cube plus y cube plus z cube is equal to 3xy. So in this, he has already told us that x plus y plus z is equal to 0. So I can simply rewrite this identity. Let's rewrite it. We will write x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square plus minus xy minus yz minus zx. So now when this will become 0, this will also become 0 because anything multiplied by 0 is 0. Then I will be left with x cube plus y cube minus z cube minus 3xyz. This is subtracting over here. On the other side, when I transpose it, it will become positive. So I will be left with x cube plus y cube plus z cube is equal to 3xyz. That's it for question 13. Moving to question 14. Now, it is actually also derived from the same equation, which says that if I have x cube plus y cube plus z cube minus 3xyz, it should give me x plus y plus z, then x square plus y square plus z square minus xy minus yz minus xz. Now over here, if this becomes 0, I will simply get x cube plus y cube plus z cube is equal to 3xyz. So this is what we will be relying on here. I can clearly see that in case of the first part, minus 12 plus 7 plus 5 will give me 0. So therefore, I can simply write this as minus 12 whole cube plus 7 cube plus 5 cube can be solved by simply writing 3 into minus 12 into 7 into 7 into 5. So I will get minus 36 multiplied by 35. So it gives me minus 1260. Similarly, let's verify the second one. So it says 28 minus 28, because minus 15 and minus 13 will give me minus 28. It's also 0. So that means it can be solved the same way. I can write 3 into 28 into minus 15 into minus 13. So when we solve it, we should get positive, because negative and negative will get cancelled. 16380. 16380. Okay, now it says give possible expressions for the length and breadth of each of the following rectangles. So I must remember that rectangle's area is given by length into breadth. So area is equal to, I must write it in the factorized form. So if I want to factorize the first one, it is clear when I multiply 25 into 12, I get 300. So in order to get 300 here, so the first part can be easily solved by using splitting the middle term if we want to write it in the factorized form. So the factors will become, as we need 300a square, will become 20 and 15. So let's try 25a square minus 15a minus 20a plus 12. So over here a and 5 is common, so I get 5a I'm left with 5a minus 3. Over here, I can take minus 4 as common. So I'm left with 5a minus 3. So I get 5a minus 4 into 5a minus 3. So this can be my length, or this can be the breadth. This can be the breadth, or this can be the length. The order actually doesn't matter. Moving to the next part, again you need to factorize it. So the factors here, when I split, can be 28 and 15, because 28 minus 15 will give me 13, and when we multiply it, we will get 420. So let's solve it. 35y square plus 28y minus 15y minus 12. Let's factorize it. In this I have 7y common. I'm left with 5y plus 4, and over here I can take minus 3 common. So I'm left with 5y plus 4. So the factors are 7y minus 3 into 5y plus 4. So again we can say either this is my length, or this is my breadth, this is my breadth, or this is my length. The order doesn't matter. Moving on, now it says, what are the possible expressions for the dimensions of the cuboid whose volumes are given? So we know volume can be found by length into breadth into height. So I need to factorize into 3 factors. Let's start with the first one. Now I can first take 3x as common. I'm left with x minus 4. So now my 3 factors are 3 into x minus 4. So we have quite easily factorized it. Moving to the next part. Now in this I can clearly see that 4k is common, so I will take 4k common. So I'm left with 3y square plus 2y minus 5. Now this can easily be factorized using splitting the middle term. So I can write it as, the 4k will remain as 4k, 3y square minus 3y plus 5y minus 5. So I get 4k bracket, 3y is common. So inside I'm left with y minus 1. Over here I can take 5 common. I'm left with y minus 1. So now I get 4k into 3y plus 5 bracket y minus 1. So I have my 3 factors, 4k, 3y plus 5 and y minus 1. So that's it for today. Please like, share and subscribe to my channel for more updates. If you have any doubts or questions, please post them in the comments and I will try to solve them in the next video. Thank you.